Alright guys, we're going to try something new. I'm going to give you your notes. So hopefully you've already downloaded this page. If not, please, before you start watching this video, pause it and go through and download this so you can either follow along or actually print it out and write your notes. Either way. Today we're going to be looking at vertex form of the equations, their graphs, and the transformations that occur on that. So remember, we've talked about standard form of a quadratic before. Standard form of a quadratic function is ax squared plus bx plus c. Remember, a, b, and c are all integer values for the most part, what we've been dealing with, or what we call real numbers. In standard form, the a value is going to tell us the direction the graph opens. Remember, we have the positive a value. The graph is going to open up, and it's going to have a minimum. If we have a negative a value, the graph opens down, and it has what we call a maximum. Also in standard form, we can look at our c value. That constant at the end will tell us the y value of the y-intercept. In standard form, we don't have to know the x value because the x value is always 0. And that's in any form. Now, we've also looked at vertex form before. We haven't done a whole lot with it, and that's what we're going to start looking at today, but we have looked at vertex form. Vertex form was that a times x minus h squared plus k. Remember my standard form, I have my ax squared plus bx plus c. So I have that x squared term. In vertex form, I have parentheses being squared for the most part. So again, my a value tells me whether it opens up or down, and my rule for that is the same as standard form. Positive a opens up. It has a minimum. Negative a opens down, has a maximum. So that doesn't change. No matter what form we're dealing with, the a value will always be the same. In vertex form, my vertex is the point h, k. The big thing is to remember that we have this negative h inside the parentheses. So when I write my vertex, I have to change the sign of the number inside the parentheses. In vertex form, the axis of symmetry is x equals h, or x equals the x value of my vertex, if you want to look at it that way. Recall that our parent graph was y equals x squared. We've talked about the parent graph. We've graphed the parent graph. We're going to look at it some more. Y equals x squared is my parent graph because that's the simplest form of a quadratic I can get. There's the x squared with nothing being done to it. Every other quadratic I have comes from this graph. So, if I want to fill in the table and graph this parent function, I'm going to fill in these x values, negative 2, negative 1, 0, 1, and 2 for my x. So when I plug in, I always put what I substitute in inside parentheses. So when I have y equals negative 2 squared is negative 2 times negative 2. So negative and negative are going to cancel, so positive 4. So there's my first point. Then I'm going to plug in y equals negative 1 squared. Again, negative times negative is going to be positive. 1 times 1 is 1. Y equals 0 squared. So 0 times 0 is still 0. Y equals positive 1 squared is 1. And y equals positive 2 squared is 4. So when I graph those points, these are what we consider our 5 key points. This is my parent graph, my parent function, my parent table. Everything we do is going to be based off this table and this graph. So when I graph these points, I have the point -2, -4. So from the origin, -2 is back 2 to the left, +4, up 4. -1, 1, from the origin back 1, up 1. Then I have 0, 0 is my origin, 1, 1, and 2, 4 are my other points. I'm going to connect my points with a curve. And because my A value is positive for this, it's going to open up, create that U shape, and I will have a minimum. When I look at this function, the vertex of my parent function, the lowest point on my parent function is the point 0, 0. That is my minimum, or my vertex. The axis of symmetry, the line that would cut my graph in half, is always x equals the x value of the vertex. So in this case, it's x equals 0. When I look at that, that means that if I take and go along the x-axis to 0, and I draw in this vertical line, which really ends up being the y-axis, it will split my graph in half. So if I were to fold the graph on that line, it would lay right on top of itself. Now, if I want to look at the graph x or y equals -x squared, that's going to have a negative a value. So I should be able to tell just from looking at that some of the things that are different about the graph. We're going to go ahead and we're going to graph that using an XY chart, and then we're going to answer the two questions. How did the table change? How did the graph change? So first of all, if I'm going to graph this, I'm going to make my XY chart, and I'm going to use those same x values, -2, -1, 0, 1, and 2. Then I'm going to plug those values in for y. So this time I have y equals the negative of -2 squared. When I'm evaluating this, I have to follow order of operations. Do not cancel out the two negatives. I have to do the exponent first, then take the negative of my answer. So negative of -2 squared, I have -2 squared is +4. The negative of that is -4. Then, same thing with -1. I have the negative of 1 squared is +1, and the negative of that is -1. I have the negative of 0 squared next. 0 squared, anytime I multiply 0 times anything, it's 0. So 0 times itself is still 0. The negative of 0, still 0. Y equals positive, the negative of +1 squared. So 1 squared is 1. The negative of that is -1. And finally, y equals the negative of +2 squared. 2 squared is 4. The negative of that is -4. So here's my chart that I'm going to now graph. When I put that on my graph, I have -2, -4. So now I'm going to go to the left. From the origin, I'm going to go left 2 and down 4, down here. Then left 1 and down 1 for -1, 1. 0, 0 is still the origin. then positive 1, negative 1, so to the right 1, down 1 from the origin, and positive 2, negative 4, so to the right 2 and down 4. When I graph that, here is my new graph. If I want to compare that to the parent function, I'm going to look and say, what happened from the red graph to the green graph? What happened from the chart up here of the parent function to the chart I just created? So when I look at the table, the only difference in the table is right here. Each one of the y values became negative. So that's my answer to that. All of the y values became negative. How did that change the graph? If I look at my graph, my parent function opened up. It was that U shape. Now my new graph opens down this N shape, and it's what we call a reflection, or it was reflected, flipped if you will, over the x-axis. So when I look at this, the whole graph, every point flipped or reflected over the x-axis. In other words, it moved to the opposite side the same distance. So if I look, my original point was negative 2, positive 4. It was to the left 2 and up 4. My new point is to the left 2 still, but now it's down 4. So it's 4 spaces below the x-axis, where the original point was 4 spaces above the x-axis. Same thing with negative 1, 1 was 1 above. Now it's negative 1, negative 1, so it's 1 below. The only point that does not move is the origin, the 0, 0, because it was already on the x-axis. So when I reflect it, it doesn't move. All right, let's look at a couple more examples that are a little more complicated. So again, vertex form.